Now we're going to get into some stuff you've probably seen in your book. And sometimes you see these derivations and they just kind of throw you off and you're like, I'm not going to look at this anymore. Work with me here. I'm going to teach you the definition of a derivative and it's going to make absolute sense to you. So you may have seen this in your book. It may not have been as clear. I hope to be clear with you here. Okay? What if you have a graph here like this? Okay? And there's some function on it. Looks like this. Okay? Here is a point. I'm going to call it P. Point P. Okay? Nothing too crazy so far, right? This is the x-axis and this is the y-axis. Okay? Now at the point P, the x value of the point P is the value a. So at x equals a, that's the x value of this point P here. Okay? Now there's also another point here, a little bit farther down the way in the x direction, the point a plus h. Okay? So here's the point A. I go a little bit farther, some distance h, right? And I get to the point a plus h. That's nothing too big of a deal. So I go up here. So I've got an intersect with this curve a little bit farther down. Okay? Now, what I'm trying to do, okay, at the end of the day, what I'm trying to do, I'm not going to hold it from you. What I'm trying to do is define the derivative of this curve at this point P. I want to know what the derivative of it is. And I already told you the derivative is the slope of the line tangent to the curve. So the line tangent to this curve might look something like that. Okay? And what I need to do is I need to find out how to calculate the slope of this line, and then that will be the derivative of this curve at the point P. Okay? So that's what I need to calculate. So let me ask you, what is the general formula for the slope of a line? The slope of a line. So don't think calculus here, think algebra. What did you define as the slope of the line? Well, you'll probably remember it was the rise over the run. In other words, you calculate how far up you go and how far over you go, and you divide those numbers and you get what you call the slope. Okay? We also wrote that as y2 minus y1 over x2 minus x1. So you take the difference, you take any 2 points in the line, you find the difference in y, how far up, and you put it here, and the difference in x, which is how far over, between the same 2 points, you put it here, you divide those numbers, boom, you have the slope. So in order to find the slope of this line, we need to use this formula. Okay? We need to use this formula. I'm going to help you use that formula. So let's look at this. At this point, what's the distance between these 2 points here? Not between these 2 points, but between these 2 dashed lines. The distance here, I already told you, was h, because this is a and this is a plus h along the x-axis. So the distance between these 2 lines is h. Okay? So if I draw me a little triangle in here, which I'm going to do in green to make it clear, here's a little triangle in here, like this. Okay, so you have a little triangle built in there. Okay? Well, look here. If you were to calculate the slope of a line kind of going through here, through these 2 points here, you could do it by looking at the rise here and the run here. Now that wouldn't be exactly what we're trying to find with this line, but if the line were going through these 2 points, we would do it, we would look at this rise and this run. So let's look at what those rise and runs are. We already know what the run is, the run over in the x direction, that's just h, so we have the answer. What is the distance here? Well, this point, okay, right here, this point right here, this is just f, because this function here is f of x. This is just f of a plus h, right? I mean, I just take the x value, stick it into f, and that's what this value is here, okay? And what is this value here? This is what I need to know right here, okay? Because I'm going to eventually be interested in this difference here. Well, the value here in y is just f of a. So here I've got f of a, and here I've got f of a plus h. So just bear with me here, I'll make it clear. This distance, okay, is just equal to f of a plus h minus f of a. I take the y value here, I subtract the y value here, which is the same as the y value here, and I get this difference, and this is this quantity here. This is my rise, this is my run. Okay? Let me write that down for a second. I'm just going to write it right here. I'm going to say the rise, which is this quantity here, the difference in y is f of a plus h minus f of a over, that's the rise, the run is just h. Now, that looks pretty complicated, but it's not too bad really. You're just looking at rise over run. Rise is defined here and run is defined there. Okay? But we're not done, because what we've calculated here is the slope of a line going through these 2 points, right? The slope of the line going through these 2 points. But that's not what we want. We want the slope tangent here. Now here, my friends, is the trick that makes calculus possible. Okay? What we're going to do is we're going to write 3 magical letters out here, and we're going to take the limit as h approaches 0. And we're going to say that when we do this, the derivative is equal to the limit as h approaches 0 of this quantity. Now, what does this limit thing mean? Usually in calculus, the first thing that you learn about is limits. I chose not to put it in the presentation because honestly it's completely ridiculous the way most calculus classes are taught, teaching limits at the beginning with a bunch of abstract nonsense, okay, that really derails you from learning the calculus, okay? But basically, a limit is a mathematician's way of saying something very simple. Here's a curve, okay, like this. So this is f of x in this axis and x over here, okay? What is the limit of f of x as x approaches 2? Well, if 2 were here, as x approaches 2, and let's say f of x, let me change the curve here. If f of x is x squared, I'm going to make it a real curve here. So f of x is x squared. The limit of f of x as x approaches 2 is 2 squared, which is 4. Okay? Really, when you take the limit, all you really do is you take the number that you're approaching, you plug it into the function, and that is what your limit is equal to. Now, the reason it's not quite so simple in the calculus books is because this works when the curve is smooth, which almost all the time it is smooth, especially in nature. Almost always the curves are smooth, unless you get into like noise and other phenomena, the curves are really jagged, but usually the curve is smooth. So when you have a limit, all you really do is you plug in the number that you're going to, and you get the limit back. So that's really what a limit is. It's just trying to say, as you approach a certain number, what does the function do? Okay, what does the function do? Here it's a little more abstract, okay? What we're trying to say is, here's the slope of the line through these 2 points, but I'm going to shrink h. I'm going to take the limit as h approaches 0. So eventually, in the limit, I'm going to converge on the solution, and the solution is going to be the slope of this line here. Because I originally started with the slope of this line through here, I'm going to shrink h, so I'm going to end up with that. So this is important. It's important for the first couple sections of calculus, but to be God honest, truthful with you, you won't use it very much in everyday life. You won't use it much in calculus. You need to learn it because you need to know how to use it on a test, and you need to know where the derivative comes from. But after we use it a few times, we're going to be working with the direct methods to take derivatives, and it's not going to be using this formula. So I'm going to teach you how to work a couple quick problems so that you can work them on your test, but just keep in mind that you will not be using this formula regularly in calculus. It's just not something you're going to use. But it is fundamentally the definition of the derivative. Okay? So let's move on and do that. Let's work a couple of quick problems, because usually in the beginning sections of calculus, the first thing they do is they introduce a derivative, and then they give you a couple of little problems to prove that you know how to do it. Well, so let's do that. So let's say you have a function p of t, it could be the position of something, and that's equal to t squared minus 6t minus 5. Now, for your benefit, I'm going to write the derivative, the definition of the derivative over here, because I know you probably haven't memorized that. And so I'm going to write it over again. The derivative at the point A, or in the previous drawing it was the point P, but it's the same thing, is equal to the limit as h approaches 0 of f of a plus h minus f of a over h. So it's the limit as h approaches 0 of this quantity. That's the definition of the derivative of the function f at the point A. Okay? So now we want to take the derivative of p prime, and I want to evaluate that derivative at the point 2. So here, if I were to draw some graph, I mean this isn't the graph, but if it would look like this, what I'm interested in at the point x is equal to 2, what is the derivative? Would be what is the slope of that line tangent to that curve? The slope of the line tangent to that curve at the point x equals 2. So how do you do that? Well, I'm going to write it over again just to make it clear. Limit as h approaches 0 of f of a plus h minus f of a all over h. Okay? So we're going to have to do a little bit of algebra here. Bear with me. This is equal to the limit of h approaches 0. Okay? What does this mean? F of a plus h. What I'm going to do is I'm going to take a plus h, the quantity, and plug it into the function I'm dealing with, which in this case is p. Okay? So a plus h is going to go here, a plus h is going to go here. And then I'm going to keep going. So what I'm going to have is, I'm going to have 2 plus h squared. Why 2 plus h? Because remember, the derivative here, this formula, is defined at the point A. That's the point you're interested in. Here, I'm interested in finding the derivative at the point x equals 2. So here, A, I'm going to fill in with the number 2. So 2 plus h squared minus 6 times 2 plus h. Again, a plus h goes in here where a is equal to 2. Minus 5. Okay? So this is the first term. This is f of a plus h. I've just plugged a plus h in here where a is equal to 2, and I get this. But remember, I've got to subtract this quantity, which is just f of a. So I'm going to have over here 2 squared minus 6 times 2 minus 5. Now why did I do it like that? Because it's f of a where a is equal to 2. So I just plug 2 in here and 2 in here, and I get this. Okay? And all of this stuff is over h, which I don't know what that is. Okay? So let's go ahead and simplify this. This will be the limit as h approaches 0. Okay? So what I'm going to do is I'm going to expand this. Okay? And that's going to be 2 times 2 is 4, plus 2 times, and then you multiply the inside terms. So it's 2 times h, which is 4h, plus h times h is h squared. All this is FOIL. The first term times the first term is this. The last term times the last term is this. And then you get the middle term. It's just 2 times the first times the last. If you go and review your FOIL, then you'll figure out that that's what that's equal to. So let's work with this term. Minus 6 times 2 is 12. And then you've got a negative 6h here. You distribute that 6 in. And then you got a negative 5 hanging out here. And then over on the end, you just kind of distribute this stuff in. This is going to be negative 4. 2 times 2 is 4 with the negative sign. This is going to be positive 12. Negative times negative is positive, and this is 12. And then the final value is just going to be 5, positive 5, because negative times negative is positive. So I come over here and put an h here. Now I had these parentheses here, but I can remove them now because I'm just adding a bunch of terms together. And I can see right away that this 4 is going to cancel out with this negative 4. They're going to subtract out and give me 0. And this 12 is going to subtract out with this 12. So they're going to be left alone there. And this 5 is going to cancel out with that 5. Okay? And so those are all go away. So this suddenly looks not too bad. So then I'm left with the limit as h approaches 0 of what I have here is h squared. That's this term here, so I put a dot over it just so I know that I've dealt with that term. But I've got 4h minus 6h, so I've got a minus 2h here on top, and then I've got an h on the bottom. Okay? Now how do you simplify this? I could say this is equal to the limit as h goes to 0. I'm going to pull out an h from the top. It's going to be h inside minus 2. All I did was factor out an h, and this is over an h. Now the only reason I really did that is because I knew that if I did that, this would cancel with this. Okay, because h divided by h is 1. So in the end, I'm going to be left with limit as h goes to 0 of the quantity h minus 2. Now here's where you can apply what I showed you just a minute ago. Here I'm taking the limit of this function, h minus 2, as h goes to 0. So what do? You just plug in 0. Okay? You put 0 in here, and then whatever you're left with is the answer, negative 2. So here, what you would write for your final answer is p prime, the derivative of this function p at the point 2, is equal to negative 2. This is the slope. That is the slope of that function p, the slope of that tangent line at p, and that's equal to a negative 2, which is a constant slope. Okay? So that means the slope is not changing. Okay. Now as you go, if you were to go and follow that curve up p, as you go up, and follow it along, the slope of that curve might change, but the slope of the tangent line is just a number because any line has a slope that's equal to that. We're going to do one more quick problem. What if you have f of x is equal to 5x plus 3? And here what I want you to find is f prime of x. Now the other problem we wanted to evaluate the derivative at a point. Here I want you to actually arrive at the derivative as a function of x. So in other words, I want you to arrive at a formula that will predict the derivative at any point x. Okay? But you really do it the same way. It's the limit of, as h approaches 0, of f of x plus h minus f of x over h. Now it looks a little different. Here it was a plus h and a. But again, whatever's here is where you're trying to evaluate the derivative. Here I told you I just wanted it as a function of x, so I'm just going to stick x in there. And eventually I will get a function of x in my answer. So this is just equal to the limit as h approaches 0 of, and what I'm trying to do here is I'm trying to put x plus h in here. So I'm going to have 5 times x plus h plus 3. All I did was take x plus h and stick it in here. Okay, minus f of x, which is just this quantity here, which is 5x plus 3. That's just f of x, over h. Okay, so I'm just taking x plus h, putting it in, getting this quantity, f of x, putting it in, getting this quantity, all over that. So let's simplify this. And I think you'll see that some stuff will cancel, hopefully, and we'll be okay. Let's expand this. This is 5x plus 5h plus 3. Distribute the 5 in. That's all we did here. Minus 5x minus 3. Just distribute the 1 in, the negative 1 in, and again it's all over h. Okay? So you can see right away the 5x cancels with the negative 5x. The 3 cancels with the negative 3. So that fortunately worked out. So in the end, it's the limit as h approaches 0 of 5h over h. Now of course h divided by h is 1, so I'm going to take that out. So it's the limit as h approaches 0 of the number 5. Now this looks goofy. I'm taking the limit as h approaches 0, but there's no h anywhere. Well, that means there's no dependency on h, so I don't even have to do anything to it to take the limit. Okay? So the answer is just 5. Okay, so what that means is the derivative of f of x is equal to 5. Okay, now just pause for a moment and think about this. Okay, here was the formula originally, the function. What is this a graph of? This is a graph of a line. Something like this. Has a y-intercept at 3. It's got some slope. You learned in algebra that the number in front of the x here is the slope. That was mx plus b. Remember that? So here I'm just showing you another way to prove that the slope of that line is 5, which is the slope here. Okay? So in this section, what we've done is we've introduced derivatives conceptually. We've said that the derivative is the slope of a line, or equivalently, if it's a curve, it's the slope of the line tangent to the curve at a point. Okay? So at any point along a curve, I can define a derivative, which will be the slope of the line just barely touching it. Okay? And so in the end, generally, if I take a formula like f of x is equal to something, some function of x, and I take the derivative of it, I will get another function which will be representative of the slope of that original curve at all of those points along itself. Okay? And so in layman's terms, the derivative of position function is like the velocity. It's the rate of change. It's the slope. It's how fast it changes. The derivative of the velocity is the acceleration. Okay, so those are just some familiar examples. But in the end, the derivative is basically the slope of the line tangent to the curve. And what we're going to do as we progress along here in the course is we're going to learn how to calculate derivatives of all kinds of functions and use them in some actual problems.